that probably will help understand big data. Big data these days, sort of a cliche, and like everybody talks about it, and somewhere if you even openly admit that there are certain things that you don't know, people will almost give you a stare that you are the moron in the room and you don't know big data. But it's not that simple. There are certain aspects and there are several considerations around it, and I will walk you through that what we have gone and see if that makes sense in a broader or generic way. So if you ask big data from different people, and I'm pretty sure even if I ask big data in this room, probably it will be the same concept where several blind men are trying to look at elephant, and they will come up with, somebody will say it's an inference problem, understanding what data means. Somebody would say it's a big volume problem, handling big volume of data at any scale. Some might say it's a big infrastructure problem, how do you scale with the increasing amount of data? And processing or compute problem. Once you have so much information, what do you do with it? And that's what big data is. Last but not least, it could be a huge storage problem. We are talking about gigabits, petabytes, and zettabytes in some cases as well. But looking at this diagram, I think it makes sense why Hadoop, the symbol of Hadoop is elephant, because it might have originated from there. So the real answer is, it is a buzzword, but it's completely okay to say that, there is no one answer, and it's majority of the people, I think 70 or 80% of the people have misinterpretation of big data and what does it mean. And, this is a famous cartoon where the company is trying to, unveil their own big data strategy, and the people are talking about when is the right time to say that I don't know about big data. So what is big data? The way I have understood it, basically it's a very simple, it's not a technology, it's not one space, it's a serialized step. There are certain steps to unfold the insight, and that is what big data is called. So it is about scalable way of generating data, a scalable way of transforming data. Once you have generated data, the data can come in many shape, way, and format. And what does it make? You have to do a lot of transformation around it to make it generic and usable. Then storing data. Once you have so much information, how you are going to store it, when you can retrieve it when you want and store it when you don't, and what is the strategy around it. This is also a part of big data strategy. And then once you have generation, transformer, and storing, what about the processing? How is the compute going to happen around it? And last but not least, analyzing the data. So once you have all these 5 steps together in a way where you can actually scale to any amount of data, any amount of volume in a very effective and time sensitive way, that whole paradigm and then whole spectrum is called big data. I just also want to make a huge emphasis on the last point, which is, if doing all this is storing, processing, computing, and doing analysis, if you are not able to make the impact, if the data is not meaningful, it's not able to make impact in your decision making or even in your business, even in your strategy, it's not a big data problem, which means you have not achieved the goal what you wanted to do with that. Many companies, they get trapped on the first layer of the system itself, and they lose the track of how to make an impact. And I'll walk you through some success story, and I will also talk to you about some failures that have happened because everything was there on top of it, but the impact, or basically the follow-up to use that insight to make a larger impact, was not there. So before I jump into that, so we all have seen what happened in 20th century. 20th century is all about oil. Even your whole geopolitical scenario, even the countries, industrialization, everything happened on based on just one entity, and that was oil. If a country is rich, if a country is poor, or any company, if it, you all know all the oil companies for 1970s, 80s, and 90s, they were the top companies in those lists, and it was all because of oil. Coming back to 21st century, the situation has completely changed. Data has replaced oil. Data is what defines what company will basically be on the top and what company will be at the bottom. You have seen example, right from Apple to Google to Facebook, all these companies, what they have. The only thing they have at this point in time is data, and they are just at a very different level of valuation, at a very different level of value that we have seen in the old industrial era. Just to give you an example, The biggest taxi company. Who is the biggest taxi company these days? It's Uber. Ola is, yeah. I mean, obviously in India it's Ola. And you know, they don't own any taxi. They don't own any taxi, they don't own any driver. So why they are valued at 40 billion or 30 billion? It's the data. They know who's looking, who's searching for a taxi, they know where the taxi is, and you know, the efficiency, the connect. The last point I was talking about, making impact of just one thing by collecting all that information is what is the reason of Uber sitting on that. Take example of Facebook. You know, a lot of people actually were upset. They got very angry that why would somebody would pay $19 billion for a chatting app called WhatsApp. But what could be the reason they paid $19 billion, and some people will still say it was cheaper? No, it's data. It's absolutely data. You know, people, if you see our communication, what has happened, the SMS, even chat, everything has gone, and all these groups have come on WhatsApp. And they never need to monetize WhatsApp at all, ever in their life, because they will see user on their different domain or even on the Facebook. All they need is basically what people are talking, what's happening, what is happening during those conversations, collecting all that data and making sense of it. So the way we value things in this age of information and data is very different, and I think that's the point I'm trying to make over here. You know, the brick and mortar, the oil economy is way behind. This is the world of data, and any company who has figured out how to deal with the data, make sense of it, and make use for the best of their business or in their decision making, I think their progress and their success will be a very different order and very different league. Look at what is happening around us. I mean, think about the mobile phone. I think I started my career with AT&T, and when I was in US, my phone was literally almost like 1 kg, this big. You know, it was barely able to call, make those calls, and it was completely an analog device. And if you see today, we are in the world of Internet of Things, and everything is through sensor driven. Even a small devices like mobile, it's not just a phone or making call or for sending SMS each other. It is actually a gadget that has 30 to 40 different sensors and segment in it. They all are generating data at this point of time. You all must be carrying a smartphone. How many of you basically use your finger to unlock it? I'm pretty sure anybody who's carrying iPhone or some of these things. Do you know there is an accelerometer that actually tracks whether you are jumping, running, walking, even fitness tool. All these data is getting generated every minute, and imagine billions of devices around the world, and they are all crunching this information. And every phone, when you see, there is an option that this data can be used by either Samsung, Apple, and all those things. And what are they doing? They're actually collecting all your sensor and all your information to basically provide you valuable result back. And if that information is not valuable, then it has no meaning of all that collection and going through the huge process. So this is the world we are living in. This is a simple slide I have put from the trend. There is a 32% increase on the devices year over year that we are carrying, and every such device coming with more and more amount of sensor and more amount of data generation around the devices, and how this is going to be used even just to improve your life. The phone has become a complete personalized or personal concierge at this point of time. Anything you want related to you, you use your phone. And today, how is that possible? It is all possible because of all this sensor and data that is getting generated. This is one of the best. I think I'm always in awe of what is the, sometimes the most beautiful and most, intricate solution of big data is the simplest one. And to me, Google Map is just the epitome of one of the most useful application ever written that uses data. You must all be using Google Map these days, isn't it? There were almost 18 companies who actually plotted the entire globe, and they created map 6 or 7 years ago. Almost, I would say almost 15 and 14 of them have vanished. And what could be the one single reason why they vanished? Yeah, I mean, so data, making sense of data is not just one time process. You have to constantly evolve, and you have to constantly make sense of it. Just 4 days ago, I was in US and I was driving, and I was using a different map for some reason. It was in that car, and you know, there's a Bay Bridge in near San Francisco. The bridge was demolished 3 years ago, and the map was showing I'm almost driving on a sea. There was no road. Because you know, they never updated their information. It's all the old thing. While if you see the Google map, they have evolved. They can even tell you where the traffic jam is there and how they are doing it. You know, a lot of people are using these maps, and they are passing all those information, and they are tracking how much time it's taking for you to cross 1 kilometer and 2 kilometer and 3 kilometer, and making sense of that direction and time. They can actually paint that road either red or green. So this is the most beautiful use of our daily life, you know, how big data can be used. And imagine billions of devices, billions of people pumping all this information, and this is how it is being utilized. Similarly, you know, this is our homegrown Axis BAM, and I just love the example what they have done. You know, one guy in their data science team figured out that 90% of the people, when they go to ATM, they actually punch and they withdraw same amount of money. You have a habit of either withdrawing 5,000, 1,000, and 10,000. No matter how much you want, you tend to just get same amount of money. You are okay to go there 2 times, but you will press 5,000, and he figured out. So what they did on some of the ATM where it was always crowded, there was always a 30, 40 people in the line, they put one simple option that just withdraw the same amount that you withdraw last time. And your withdraw step just became three-step process. You put your ATM, you press that button, the money is out, you take your card and you're out. The lines were reduced by 78%, and their computation went down drastically because majority of the people were just opting for that option. It is so simple. And this is the basic use. When you have all this data, when you put together and you can make sense of it, beautiful things happen. And I think that is the real power of big data. I will also very briefly cover 2 failures also. Have you guys know MySpace and Friendster? They had the social network in 2001 and 2, and we as a company InMobi, we were actually able to work with them in 2007 and 8. They had huge scale, huge amount of data. They did everything what I talked about in first line, generating, transforming, you know, analyzing, computing, but they just couldn't create the impact. Facebook came from the behind 2007. They put all the feed together. They connected your friends and family, brothers and everything together, and voila. All other social network died in just 3 years. Everything gone. So I think this is the power of this new world we live in, and this is what big data means. Always focus on the last thing, making impact. Everything starts from there, and then what, you know, the first line that I said is what you have to talk about. Some consideration when you are thinking about big data are basically in 3 directions. One is infrastructure, software, and people. All 3 are very important. I'm not saying what is important, what is not, but these all 3 aspects that everybody has to think, and it could be very different and vary in your own domain. So I will just basically walk you through our journey over the last 4 years, what we have done. So this is the current scale that we are basically solving in our big data. We have 2.2+ trillion ads every year, 1+ billion user that we basically see on our network, almost 44 billion programmatic ad requests that we get, and almost 86 million total Hadoop jobs submit in a year. What I want you to do, focus on some graphs over there. Look at those percentage. These are the growth that we are seeing year over year, 800 plus 49,000. I mean, you cannot predict, and you cannot make, you cannot even predict these kind of growth in generation when you're doing any reasonable calculation. But this is the world of big data, and this is the kind of growth you should be able to handle. And that's where basically it's not about you know, just putting something together, but being able to predict unpredictable thing and able to grow with that is what big data challenge is all about. There are several considerations while you are making what to do and how to solve this. There's always a cost versus efficiency, and every company can have a different scenario. When we started, the cost was a huge consideration for us. We were a small startup, and the only place I wanted to spend money was on my engineers and not on anything else. But like I said, there are different ways to cut it, and it depends on company to company. These are the a 2x2 metric, the framework approach that we applied. Basically, there could be enterprise software solution to solving big data. There could be open source software, scale up system, and scale out. Once again, there's no right There's no wrong. It's based on what approach you want to take over there, and none of these are mutually exclusive. They can be combined together. What we chose is basically open source. And like I said, the first reason for us to choose open source is obviously free. It is community-led. A lot of people basically help you to write the software or build the software that you want to use. It is technology first. Everything is from the ground up, and the latest and greatest stack. You get to work on it. Usually easy to pick up. Open source is basically it has grown a lot in the last couple of years, and any engineer can learn and pick up very fast. Great way to hire good engineers. This is one of the biggest things that we have learned. These are some of the things that excite some of the rock star and some of the people that you want to have in your company. So this is a great way to attract great talent and do something phenomenal. And majority of the company these days, basically they use in their system, so they are quite proven and tested, not like earlier days. Can be deployed very quickly with no bells and whistles, very simple to install, and those sort of things. So. And then mostly compatible with any kind of hardware. You don't need any kind of consideration whether I need this specific server or what. And very agile, and you're always with the latest cutting edge technology. Having said that, every good thing comes with some bad component too as well, and we learned it hard way. The software can be shaky and unstable at some point of time. There's always a learning curve. It's a new software, people have developers, and you have to use it, so you need to be ready to learn along the way how to use it. They are community-led, so you might find a problem which basically are not solved, so you should be ready to solve those problems as well. And good engineers matter a lot, because there's no 1-800 number that you have to call if you are in the middle of a problem. It's your own team that are going to solve it. Last but not least, investment in terms of time and code is needed. And my suggestion to everyone, understand your business risk before you basically take any of those decisions. They are very important. Always contribute back. You have used the free software that somebody else has written, so it's our obligation and it's your obligation to contribute that back. And I'm very proud that InMobi has been contributing to a lot of stack, and the community thrives on basically give and take. So that is also one of the important aspects of open source. So what we did, we started very early when we were even dealing with GB data. Gained operation inside, we learned how to basically make system runs. We handled failure at a very small scale. It was very easy to handle them and use at that point of time. Made our software battle tested even in very, very early days, so that we had the formula to scale out later on. And then basically invested in tech and people massively, so that whenever we come across an unknown problem, we are ready to take that challenge. And we basically, at every point of time, we validated our business risk and appetite. This is just one schematic. I just want very quickly, I'm running out of time. So when we started, basically, we were serving ads from all over the globe. And these are, let's imagine 4 points in globe. We were collecting all the information, but we were processing them at a central location, and that became a bottleneck when the GB became terabyte and terabyte became petabyte. So there is no solution out there. So we came up with our own solution, where we broken up our Hadoop cluster into mini cluster across all the geolocation, and then we started processing information over there, and then we moved everything to the central location. So this is just one example how you have to basically find your own solution while you are dealing with this. But like I said, this is just putting whole thing together from collecting the data, transforming the data, and making sense of it in the end. But always stay true to the last point that I was saying. If it's not making impact, it's not a big data problem, and you have just solved the infrastructure or software problems. Thank you, guys. If you have any question, you can reach out to me.